Okay, so here we have to calculate the EMF for this cell. And there is a way of calculating it without making a mess out of this. Okay? And our purpose is just to calculate the EMF, not to know every single detail about it, okay? Not for now anyway. We will do that maybe in another class. So the E of the cell is equal to what? Cell potential is equal to what? Cathode minus anode. Yes? But it's the reduction potential of the cathode minus the reduction potential of the anode, yes? In other words, I have to find out which one is the cathode, which one is the anode, find out in the little table which one is there, and then just determine cathode minus anode. So, oxidation numbers. What's the oxidation number on oxygen here? -2. Oxidation number on oxygen is -2. How many oxygens are there? 7. So this gives you -14. Is the oxidation number on oxygen -14? No, it's -2. Now, what this side is looking at is how many minus charges coming from all of these oxygens. It's seeing -14, yes? So I have to add a number to this -14 to get -2 at the end. What number is that? 12, plus 12. Plus 12 minus 14 gives you -2. Okay? Now, this plus 12 has to be distributed on this side. And there are 2 of them on this side, yes? So it has to be distributed equally among those 2. So it will be plus 6. Oxidation number on chromium there is plus 6. You go to the other side here, and this is a monoatomic ion. What's the oxidation number on chromium here? Plus 3. Tell me, what happened to this chromium as it went from plus 6 to plus 3?
Gained electrons.
Did it lose or gain electrons?
Gained electrons.
It gained electrons, so we are going to call this what? Leo or GER? GER. We're going to call this GER. So we already have what? The anode or the cathode? Anode or cathode?
Cathode.
We already have the cathode. We already have the one that is a reduction. What type of agent is this?
Oxidizing.
Oxidizing agent. Which one is the oxidizing agent? This is the oxidizing agent. Oxidizing agents are reactants, yes? So this is the oxidizing agent as written here. This is the oxidizing agent.
The whole thing is CR207.
Yes, CR207. We know which one is the one doing the stuff inside of it, which is the chromium plus 6. So, and what happened to the H? The H went from plus here to what here? 0. What do you mean 0? H2 will be 0. That's not 0. That's H2O. It's not close for you? H2O. It's not 0. What's the oxidation number of hydrogen here?
Plus 1.
-2 for oxygen, and this is plus 1. 2 plus 1. So hydrogen didn't work from here to here.
Nothing.
Nothing. So that was not part of it. What happened to I? As it went from,
-0.
this is from -1 to 0. And what happened? Did it gain or lose electrons? Gain or lose electrons? Lost electrons. And this is called Leo. So what type of reaction is this? An oxidation. This will take place where? Hello?
The anode.
This will take place at the anode. So I will look in the table. And in the table, I will find those 2 numbers, yes? What are you going to look for in the table? You will look for the reduction will be higher, yes? Should be higher. I mean, which one is the reduction here? The reduction is this one, which is the cathode. So you should have on the table this plus something else, who knows what it is, will give you that, is what you're going to see. And if you have that, and which one is the other one going to be? Are you going to see I minus to I2 on that table? You're not going to see I minus to I2 on that table. Because that reaction is what type of reaction? An oxidation. What you're going to see on the table is a reduction. What you're gonna see on the table is this I2 will be on the left-hand side. Okay?
Okay.
Yes or no?
Gonna be the inverse of the sign? or-
Yes.
Okay.
Yeah, that's why you have a minus here, because the anode is not a reduction, the anode is an oxidation. That's why there is this sign here, but you don't do anything with that. So if we look in there, the cathode would be 1.33 minus 0.54. The EMF of this cell will be 0.79 volts.
So in the chart, 0.54.
Yeah, so in the chart is
That will be
the-
positive, basically, on the chart, and then because you put it in this equation, it became negative.
In the chart,
That was
yeah, this is
positive.
positive, that's positive, this is positive, they're both positive.
So even though it's the inverse of what shows in the table, you don't have to flip around the signs, right?
You did flip around the sign, yeah, right? The sign is flipped here.
No, but what I'm saying, you plug
The
in the
process
equation
was
the
the
exact
same.
same number as in the table.
As in the table, yeah.
Mhm.
Because this negative here
Already
is there to
complicated.
flip the sign. So you just use the negative and only use the numbers from that table. Do not change the sign of any of those numbers. Just use the numbers as you see them, and just use that negative.
Okay. I think that's CCl.
This is CD, okay?
Right?
Cadmium?
Yeah, cadmium. What I want you to do from those numbers is create a voltaic cell and calculate the EMF of that cell. I want you to tell me which one is the anode and which one is the cathode. So which one is the cathode and which one is the anode?
CD is the cathode.
Okay, who gains electrons? Cadmium, right? Both gain electrons. Oh, never mind. Who's the highest value? of
There-
cadmium?
They're the
Those are
same.
both reduction potentials, yes?
Mhm.
They'll both be reductions. You have to tell me which one is the cathode and which one would be the anode.
Okay, which is the highest value? That's the cathode.
The highest value will be the GER, yes, which is the reduction. And the reduction will be the highest reduction potential, yes?
Yes.
The highest reduction potential is the highest number. Is the highest number point minus 0.4?
SM.
0.4 appears to be the biggest number, yes? When I look at it, the first time I look at it, I want to, oh yeah, this is bigger. But it's a bigger negative, yes? So this is actually smaller than this one. This one is a bigger number. Yes or no?
Mhm.
Because this is a bigger number, this has the highest reduction potential. It's a confusion, okay? Which one is GER then from here? This one or this one? This one is GER. Guys, do you see that this number is bigger than that one?
Yep.
It's big number minus little number, yes? So this is Leo. So this is the highest reduction potential. So when I'm gonna calculate the EMF of the cell, it will be big number, Minus-
small number.
little number. What's this going to give you? Hello? Ms. Rodriguez, what's it going to give you? You don't have a calculator? What's so quiet today? You feeling sick? No? I'm
It'll be-
surprised you came to class since you have to study for a test you have today.
0.267.
0.267?
Yeah.
0.267?
Yep.
0.267 what?
Volts.
Is that positive or negative? It's
Positive.
positive, of course it's positive, we made it positive, yes?
Mhm.
We chose it. So let's talk about which one is the reduction. Which one is the reduction? Tell me the reaction for reduction. Sn2 plus 2 electrons will give you Sn solid. The other one on the top, is it going to be a reduction? No, it's going to be an oxidation. It will be the reverse of that, which is Cd will give you Cd2 plus 2 electrons. What happens to the 2 electrons? They cancel out. So when I add these two reactions, how would it look? It would look Sn2 plus Cd solid will give you Sn solid plus Cd2 plus. You agree, yes or no?
So there the CD0 will be the higher oxidizing potential. Which one
The
is
what?
the higher oxidizing potential?
The highest oxidation potential is Sn2 plus, because it's the reduction. Yes?
But it's reducing. The SN2 plus is reducing. Will be the highest reducing potential.
For which one? No, it would be Cd.
CD0, right?
Yeah.
Okay.
So from these two here, I can ask you, which one of those two has the highest, let's say, both of these are reductions, yes? I can say, which one of these two will have the highest which one would be the highest oxidizing agent? Or which one will be a strongest oxidizing agent, let's say? Which one is a stronger oxidizing agent from Sn2 plus and Cd2 plus? Sn2 plus, because it is has the higher reduction potential.
Okay.
Hello?
Mhm.
From those two, I can compare those two. They're both reductions right now. And from the other two, Cd and Sn, which one of those two will have the highest reducing, or which one will be the strongest reducing agent? Strongest reducing agent, Cd. Okay, you place them on a little table, yes? Some of you are still tripping about this. Which one go on the top? Which of those goes on the top? Sn. Sn goes on the top. Yes, whatever. Sn solid. And which one goes on the bottom? Cd. And this is Cd solid, yes? The ones on this side are called what? Strongest? Because these are reductions, the reverse of a reduction. Strongest oxidizing agent. So I can compare these two and say which one is a stronger oxidizing agent? The one on the top. If I compare these two on this side, on that other side, I can say these are the strongest what? Reducing agent.
So how do we know which side is being compared?
Because I ask you, I give you them to compare.
Okay.
I either give you these two or give you these two. Okay? I give you these two, which one is the strongest reducing agent? The one that is lower, yes?
Okay.
This is the strongest reducing agent. This is the strongest oxidizing agent from these two, and this is from these two. Now when I mix them together, when I pair them, this will be the reduction, but that will be switched, yes?